Good morning, learners. My name is Masweu, the subject advisor for mathematics in the Free State. I'm here to discuss with you differential calculus, which is a topic in mathematics which is well known to you. I want to say to you, just take a rest and be ready for this topic. In fact, I already know that you're itching to have the overview of the whole topic and an overall understanding. As a result, I so wish that I will be able to assist you to have that, better understanding. We are discussing differential calculus. And first of all, I would like to start with what we'll be doing. As you can see, we've got calculus day 1. During the first day, today, the next 2 hours from now, we will be looking at limits, which is the branch of calculus we're doing. From limits, we'll look at the average gradient, as you can see. And then we will also look at the gradient at a point. And then from there, we will introduce a topic on derivative from first principles. And then from there, we'll look at rules of differentiation today, and then the gradient of a tangent to the curve. We are not just only going to focus on that, but we will also be looking at the mistakes that you're doing when you are solving problems in calculus. We will also looking at notation mistakes that you're doing and some other errors which leads you to forfeiting marks. We will also have a look at allocation of marks in this calculus. Let us start. We're starting with limits. The concept of a limit. I think I'll do much of the writing. First of all, let's look at limits, like I said. All right. Right. If we have a function f at x, which is given by x, we know that this function is actually a linear function. Now, let's have a sketch of this linear function. In simple terms, you know this function as line y is equals to x. And I'll quickly draw it. There you have it. Right. Now, if we want to determine the limit of f at x as x approaches some value, let's say 2, we're actually looking for the limit of this function as x approaches 2. Now, take your 2 there. Now, in this function, what is f at 2? Your f at 2 is actually 2. So when x is 2, your f at 2 is 2. Now, we want to look at the behavior of a function f at x as x approaches. I'll use a different pen to show you that. As x approaches 2 from the left, and later we'll look at it as x approaches 2 from the right and see what happens. In simple terms, when x is minus 3, if I'm to make an example, minus 3, our y is minus 3. So when x is minus 2, our y is minus 2. So let us have a look at what is actually happening. I'll use another different pen to indicate where y values are heading. Seem like they are going like that. As x in green is approaching 2. At first we had minus 3, and we increased x. It went on to be minus 2. You will know that if it's minus 1, it will be minus 1, and 0, it will be 0, and so forth. So when it is 1, it will be 1. When it is, okay, we are approaching 2. Right. We see that the values of x are getting closer and closer to 2 when x is getting closer and closer to what? To 2. Right? But now, we must also check what happens when you're coming from the right. If you take, say, positive 4, then we had 4. If it is 3, we have 3. So we see again that the limit, these values are approaching 2 again from the top there. So we say the limit as x tends to 2 of the function f at x, we say it's equals to 2. That's how we dealt with the limit function. I just took this one, which is very basic, but let's again look at the limit as x approaches 4 of a function 5. Let me write it first as f at x is equals to 5. I think it will always be very, very important for you to draw your function. If your f at x is equals to 5, let's quickly have a look. It means when x is some value minus 1 or minus 2, how much is your y? It's 1, 2, 3, 4, 5. Let me take it there, my scale. Mind my scale, it's not very good. When x is minus 2, your corresponding y is 5. When x is minus 1, your corresponding value is minus 5. When x is 0, you have minus 5. When x is 1, you have positive 5. When x is 2, so you have some constant function, unchanging. You get the same y value all the time. Doesn't matter which x you substitute, you get the same value. Now we're looking at a case where, mind my scale again. We're looking at a case where x is approaching a value 4 from the left. We use a different pen again. Right? Your x values are getting closer and closer to 4 from the left, and they are getting closer and closer to 4 from the right. And we're saying, what is the limit of this function f at x? This is the first one. This is the second one. What is the limit of f at x, which is equals to 5, a constant function, as what? As x is approaching 4 from both sides. We see that you get a value 5 all the time. Therefore, that limit will not change. It will be 5. You are doing high school mathematics, and you definitely should understand that a limit can be asked on any kind of function. I've looked at a constant straight line functions. It can be asked on the one which is having a down slope, or the one which is having an up slope, increasing. It can also be done on, I've already shown, a constant function. An example is that one just done above. But again, we cannot limit it to that. We can also go on to a quadratic function. F at x is equals to, let me change to 2x squared. All right. The limit of this function, find the limit of f at x as x approaches minus 1. I'm making an example. Now your f at x is actually a parabola. I think my paper is down. I want everybody to see what I'm doing there. This is a function called a quadratic function, which is equals to the limit of, as x approaches minus 1, of 2x squared. Right. You know that the function x squared, it's the standard function there. But immediately you change the value of a, you're actually increasing it becomes slopey. Let me use a different pen. It becomes slopey. So this is 2x squared. Now, you want the limit of this function as x approaches minus 1. Well, this is the same as, well, the normal way. It's 2 into minus 1, which will equals to minus 2. Right. I do not want to waste much time of yours on this limit function. I would like us to go straight into problems and then and look at more, limits. I will give you some 1 minute to go through the first one. And then I'd like you to give me an answer. Unfortunately, I cannot hear you, but your teachers out there can hear you. What is the limit of 7 as x approaches 1? I think you need a second to answer that one. That limit will be 7. Now, what will be the limit of x plus 4? Maybe I should project these. Let me quickly project these so that I use my paper for writing. All right. There you go. These are the limits I would like us to have a look at. All right. We want you to determine the limit of 7 as x approaches 4. Or else do the limit of x plus 4. What kind of a function? What I want you to keep in mind is to always think of that as a function. X plus 4, what kind of a function is it? It is a straight line which has got a vertical shifting of plus 4 units. And then its limit will be 6, because it will be 2 plus 4, which will give you 6 as x approaches 2. But to have a more better understanding, I think the geometric representation will give you a better understanding of what we're talking about. I will do 3, 4, and 5 together with you so that we see if you really understand the concept of a limit. And the geometric representation plays a very vital role. Right. I just want to quickly switch on to my piece of paper so that we do the first one. The first one I said it will be the third example, which is the limit. Number 3 says the limit as x tends to 1 of 2x squared plus 1. Now, this limit is equals to the limit. Okay, I think I should remove the limit now because I'm already determining it. It will be 2 into 1 squared plus 1, which will be equals to, I've just scratched out the limit, be careful of that. This will give you 1 squared is 1, term is 2, it's 2 plus 1, which is 3. So this limit, I think you should pat yourself on the shoulder if you got it right. Be happy. We're going to come across more challenging problems. But what I'm interested in is, let's have a look at the geometric representation of this. This is a parabola, which is more steeper than the normal one we know and has shifted 1 unit up. Right? As you look at it, what will be its limit as x approaches a value 1? Right. We are saying, what is happening as x values are getting closer and closer to 1? Aha, from the left, look at it. Where is the function going? Look at the y values. It's getting closer and closer to some value. Maybe it even passes it. First of all, you need to know how much is f at 1. It is equals to 2 times 1 squared. I've already written it. I wanted a geometric representation. It is 3. So f at 1 is equals to 3. Now we are saying as x approaches 1 from the left and from the right, where is the function going? There was a case which was minus 1, where it was also 3. It went past, it turned back. So from the right again, you see that your y values are approaching the value positive 3. So when x is approaching 1 from the left and the right, the function is getting closer and closer to 3. Hence we got that limit as we see it. Let us quickly look at example number 4 from this one. Example number 4 says your function is a squared minus 4a plus 3 divided by a minus 3. Now the question is, what is the limit of this function as x approaches 3 or tends to 3? Remember, from both left and right. Good. Okay. You may be having a problem of representing this geometrically, as you seem not to be used to it. But let's quickly have a look at it. If you do a direct substitution like we did there, you will realize that you get 3 squared is 9. 9 minus 4 times 3. 9 minus 12. That's minus 3 plus 3, you get a 0. So you get a 0 on top, divided by 3 minus 3, you get a 0 again. So the question I'm going to ask is, you know in mathematics that if we have 0 over 0, or something over 0, even your calculators are giving you a mathematical error, which means you have done a maths error, which is not permissible. Now the question is, we realize that these kind of limits are actually, you get something indeterminate. This fraction, it's indeterminate. See? Now, don't be too quick to say, I cannot determine that. What you need to do now is to first simplify and see if you cannot work out something. So this limit, as x approaches 3, let us play with our skill of factorization, where we factorize that quadratic numerator. And then the factors are a minus 1 into a. Look, I'm just putting them. Because I have a plus 3, I determine the product of 3s minus 1 times minus 3. But to check whether my factors are correct, I multiply outers and inners. So minus 3 minus 1, that's minus 4, which means my factors are correct. If I had a plus 4 there, I would determine the product of outers and inners, which are, this would be a positive. Say I make a mistake and make it a negative. I'm saying if it was 4x, positive 4x. Say I make it negative, I would have minus 3x plus x gives me minus 2x, which is not working out. Here, let me repeat it again. Say it was plus 2x. So I'll change around my signs and have a plus 3 and minus 1. Then I'll say 3 minus 1 is plus 2. Then it's the same as my middle term. Then I have tested that my factors are correct. Right. Now, in this case, I have just simplified this fraction to be algebraic fraction, to be the way you see it. And now, we will cancel out the a minus 3 because it is the same. And then this limit will be estimated with the limit of, as x approaches 3, of a minus 1. I'm leaving it like that. I want you to have a look at it. This is a very dangerous mistake that I will talk about even later in my presentation, because learners do this kind of a mistake. This means the limit of a as x approaches what? As a. It should be a. Let me quickly correct this. I made a mistake here. It should be a. As a approaches what? 3. A tends to 3. But this is the limit of the first term. You're having 2 terms here. So it is not the limit of the whole thing. As a result, you're already off track. You've made a terrible mistake, mathematical error again. So you must put it in brackets. It's very, very important. I will, look at it again when we do dealing with differentiation from first principles. Right. Now, this will be the same as what? See, now, it's normal indeterminate, like we look at it. It's normal, you cannot say now I can't determine that, because this limit is actually 2. It is 3 minus 1, which is 2. Replace a with what? With a 3 minus 1, which is 2. So we have dealt with that problem. And then let's go on to the next one. Let me again remind you, what was the next problem? I will quickly go back to